I want to give quickly the solution for quiz 4. So there was the main question was find the basis for the column space and also for the row space of this matrix. And of course, the first thing we have to do is to get it in row reduced form, or at least, no, for this question it's enough to just echelon form. Okay, so we have to do, we're going to use this pivot, and therefore the row operations are row 2 minus 2 times row 1, row 3 minus 6 times row 1, and then row 4 minus 2 times row 1. Okay, so what we get 1, 3, 0, 2, 0, 0, so we're doing this times negative 2 and then add up that 0, 1 minus 4, that's minus 3, and then 7. Now we're going to do this times negative 6 and add it up there, so there's going to be a 0 there. That is minus 18 plus 8, that is minus 10. I'm sorry, I thought so there was something wrong, because I copied it wrong. This was the actual matrix that we originally had, and so of course now we get 0 here. I kind of knew that this was should have happened, so that was wrong. Okay, and then minus 6 to that, that's just a 0. Minus 12 plus 1 is minus 11, and that's just 33. And then the last thing we do is minus 2 and add it up to here. That's 0, 0, 0. Minus 4 plus 1 is minus 3, and that is 7. Okay, so we have our first pivot. We immediately have our second pivot, and look what a nice present I gave you. You don't have to do anything anymore for that pivot. This now, so we're left with, remember, we always, once we have a pivot, we don't work with them anymore. We go look at here. And there are two possibilities. Now, this seems to be the bigger number, but it's actually better to work with that because I can factor out minus 11 here, right? So I'm going to do row 3, replace that by minus 1, 11, row 3. And that would give me 1, negative 3. I'm going to be lazy and again do already this, the simplification here. Don't do this on a quiz, right? Because then I don't see it. So, what was it now? I said 1 and negative 3, right? Okay, yeah, so this is now gone. And so we have our pivot here too, but we need to do one more row operation with this pivot. We do row 4 and add 3 times row 1 to that. Not row 1, row 3. And so we have 1, 3, 0, 2, 0, 0, 0, 1, minus 3, 7, 0, 0, 0, 1, negative 3, and then 0, 0, 0, 0, minus 2. Now, again, what did I do wrong? Because I know it's not supposed to be like that. 9. Okay, I did something wrong, right? In this row, I had to multiply with negative 2 and add 2. Where did I get this from? Where does this 7 come from? This was a 9, right? Okay, and so now if I add this minus to multiply this, we will multiply this with 3 and add it up to the other one, so we get 0 here. Sorry, guys. Okay, so we have now our 3 pivots, so let's make them blue, right? So these are the 3 pivots, and this is a 0 row, so we can scratch that out, and this means that these 3 rows is the basis for the row space. It's enough if you write it this way, you don't have to copy it again. That's okay, and then for the column space we can also go there because we have now the 3 columns that correspond to this. But remember, now I have to go to the original one, so this column, and this column. So let me just circle them. Again, if you do it that way, that's fine, as long as I understand what you're doing. So this is the basis of the column space. That's these 3 vectors, and we know that they are the same, right? I mean the number, how many there are. There's 3 basis vectors for the null space, for the column space, and 3 vectors for the row space. That's the dimension that we talked about, but that's not the question. Okay, so that solves the main question. That's 10 points if you have this correct. If you make mistakes, like I kind of was doing all the time here, but you see, one mistake leads to a totally different answer. It's okay, I will double check it, and that you still worked, reasoned correctly after your mistake, and then it won't count that much. So now, what about the null space? So the extra credit problem, we needed to do the null space. And for that, we need the reduced echelon form. Okay, at the moment this was the echelon, but we need, for that we need the reduced echelon. That's why we need a little bit more. That's why I made an extra special credit problem. Okay, but it's luckily not too much work. It's actually here the only ones that we need to do is get rid of these two. So the row operations that I need to do are, I'm going to work with this row, right? And row 2, replace that by row 2 plus 3 times row 3, and row 1, replace that by row 1 minus 2 times row 3. So what do we get? Let's start with row 1. 1, 3, 0. Now here we're going to do something. Okay, we multiply this with, remember, we multiply this with -2 and then add up to this top one, that's 0. So that is -2 times -3, that's 6, plus 0, that's 6. Okay, and what was the other one? Ah, yeah, now I'm going to multiply this row with 3 and add up to the second row. We get 0, 0, 1, that gives me the 0 I want. Then -9 plus 7, that's -2. And then finally I have 0, 0, 0, 1, -3. Great. So we still have the same pivots. Let me mark them one more time. These are my 3 pivots. That tells me that the other 2 are x2 and x5 are my free variables. So I have to now write all the variables in terms of these free variables. And that is, one more time, right? There's an x1 here, there's an x3 here, an x4 here. And this means that this first row means that 1 times x1, 3 times x2, plus 0 times plus 0 plus 6 times x5 is equal to 0. So this means that x1, bring the other to the other side. So let me write it as it, x1, x2, x3, x4, x5. Okay, and it sometimes helps if, I mean, visually that these are the green ones, right? x2 and x5. So on this, in my second part here, I should, in this part, I can only have x2 and x5 occurring. Okay, so x1 is equal to minus 3 times x2, bringing this to the other side, and this also minus 6 times x5. x2, well, x2 of course is just x2. x3, well, we have this equation, so that is, we bring this to the other side, we get a plus x5. x4, well, we have this equation that says it is 3 times x5, and then x5, of course, is just itself. And there's one more step. We have to now split the part that has a x2 in it and the part that has an x5 in it. That gives me 2 columns. In the x2, we have a -3, a 1, and for the rest, all zeros. And for x5, we have a -6, where did it go? 0, 2, 3, 1. So I'm looking here at the coefficients of x5. There's nothing here, so these are the coefficients of x5, and these were the coefficients of x3, and the rest were 0. So meaning, therefore, this is the basis of the null space. Okay, that's it.